everyone, we're getting ready to start Unit 2, Research Methods, Thinking Critically with Psychological Science. The unit overview for this unit, we are going to split it up over a total of 5 days, the last day being the exam day. Talk about the need for psychological science, how do psychologists ask and answer questions, statistical reasoning in everyday life, and the frequently asked questions about psychology. For your lesson today, Lesson 1, Unit 2, students will be able to explain why psychology is considered a science and describe the advantages and disadvantages of research methods. The need for psychology as a science. Why does it exist as a science? Did we know it all along? So question. If I were to separate two groups of people and I were to tell them love makes the heart grow fonder, or distance makes the heart grow fonder, and I were to tell the first group that that is not true, that distance really does not make love stronger, we would find that the majority of the people in that group would say, you're right, it does not make them grow fonder. There's a lot of problems with long-distance relationships. It doesn't always work out. If I were to take the second group and say, distance makes the heart grow fonder, they may say, yes, it does. Example of, some friends of mine who lived far apart and it made their relationship stronger. Well, excuse me, the theory behind this is twofold. The first is hindsight bias, and that's the tendency to believe after learning an outcome that one would have foreseen it. For example, love makes the heart grow fonder. Kind of this I knew it all along phenomenon that yes, I knew that distance wasn't a good thing, or I knew that distance was a good thing. The second part of this is what we call overconfidence. And together with hindsight bias, it can lead to an overestimate of our intuition. So we tend to be more overconfident in knowing things than we actually do know. Another fun little example for you. If I were to give you the first set of letters and ask you what those spell out, now that you see it, you would say water. Another example, these letters spell entry. Well, now, so this next example, if you take a look at these letters, can you try to figure out what those letters may spell? If you got chaos, then you're right. So if you see the word chaos now, when you look at these letters, you can see how we got that, but that's, now that you have hindsight and overconfidence together, makes us think that we knew it all along. Critical thinking is part of turning psychology into a science, and there are 4 elements to critical thinking. The first is examining assumptions, discerning hidden values, evaluating evidence, and assessing conclusions. We're going to talk about all of these as we go through the scientific method. So how do psychologists ask and answer questions? Well, that's with the scientific method. And the first that comes up is a theory. So we have this general idea of why something might be happening. So we might make an observation of something. We might have a behavior that we want to try to understand. And so we come up with a theory or a general explanation of why something might be happening. The next step is we have to test that theory. So now we have to take that theory and turn it into a way that we can test it. Some way that we can either confirm or deny what is happening. Which then takes it into an operational definition, which is a statement of the procedures that we use to define the research variables. So we have to come up with essentially a description of how we're going to do this. So the first is just a general idea, then we turn it into a question that we can answer, and now we come up with the steps of how we're going to do that. before finally determining whether or not we can repeat it. So one of the most important things with an experiment using the scientific method is you have to be able to replicate your data. You can't just do it once and say this is accurate. We know a theory is good if you can use it for the following. If it can effectively organize a range of self-reports and observations, and can imply a clear prediction that anyone can use to check the theory. So again, you have to come up with something that's clear and specific so that other people could potentially use that. So descriptions. After we come up with our scientific method and we follow through our steps, we might go about it in a couple of different ways. And the first is a case study, and this is when we study one person for a long period of time. The positive about this is that it could suggest us other areas to study and focus in because we get a lot of information about one person, so it might inspire new studies, which is always important when you're researching. The con, however, is that it could be that that one person is just unique or atypical, and so it's not really setting a standard or setting an example for how others may act. On the flip side of this, you could do a survey in which you study a large group of people over a short period of time. So this is where people self-report an attitude or behavior, and it's of a group of people. A positive is that you can look at a lot of different people all at the same time. However, a negative is the way that you ask your questions and the sample that you choose. So if you want to know about somebody's political beliefs, but you interview everybody from the same political party, you may not get an accurate representation as if you interviewed people from all over and all different types of political beliefs. Part of this is word effects and the way that you ask the questions. You can also say framing or, when we talked anything about in the last unit about the way that you set up a question. Also, your sampling. Who are you surveying? How big of a population are you surveying? And are you choosing them random, or is it a representative sampling? So random means that you're just picking whoever. Representative means that you're trying to represent a certain group of people. The next way to collect information using the scientific method is naturalistic observation. And this is where we observe somebody in a natural setting without trying to control or manipulate anything that's happening. A positive is that we can describe behavior that we see. A negative is that we can't explain why that behavior is happening. We can't ask that person because we don't want to disturb the situation. However, one concern is what we call the Hawthorne effect, and this is when even though you may not be talking to that person and you have them in a natural setting, they still may know that somebody's observing them, which may change and alter their behavior. So after we get this information, we're trying to determine correlation. Does something cause something else? So how well would A predict B? And does it predict it in a positive way, or does it predict it in a negative way? And we measure this on a -1 to +1 scale using scatter plot data. So for example, if I wanted to know, does the height in men impact their overall temperament? So temperament is their just overall attitude. So if I take their height in inches and then I give them a temperament scale, does how tall they are impact their temperament? So I would take this information and I would dot it on a scatter plot, just like you see here. And as you can see, the dots are very loosely correlated, but in an upward direction. When we see it go from down to up, we call this a positive correlation. This would be an example of a perfect positive correlation right here on the right-hand side. The dots are going straight up. If we were to flip that around, it would be a perfect negative correlation. Or we can have no relationship, where the dots are just scattered all around. Now, this is really important because we're trying to figure out if something causes something else. If we see this happening or this happening, we know that yes, those two things are related. If we see this, we know that no, those things are not related. Some important things to know is that correlation does not mean cause and effect. Some examples. First of all, low self-esteem could cause depression. Or depression could cause low self-esteem. So we don't know, was it the chicken or the egg? We're not sure what came first. Was it the low self-esteem or the depression? But we know that those two things might be related. And finally, we could have something totally separate, like maybe there was an event, or they might have a biological predisposition, meaning something in their genetics, which causes both self-esteem and depression. So just because some things are related, we don't necessarily know that one causes the other. We just know that there's some sort of a relationship between those two events. And that is it for today. Okay, I lied. That wasn't it. My fault. There's two more things. When it comes to correlations, sometimes we're fooled. And there can be a perceived non-existent correlation or a random coincidence that things just happen. So, for example, adapting versus don't adapt. If you adapt, sometimes we see that people still end up getting pregnant, right? They still end up conceiving. Well, people say, oh, well, it's because they learned they were adapting, so therefore they were able to easily get pregnant. Or you can say that they adapted and they didn't get pregnant, and so therefore that was a good thing that they adapted. Adopting a baby has nothing necessarily to do with getting pregnant or not getting pregnant. This is a non-existent correlation. Does it happen? Definitely. But does it happen all the time? Definitely not. So there is no correlation there between these two things. Also, sometimes perceiving some sort of correlation in something completely random. And this comes because sometimes we just want to make sense of something. It's like a coin flip. There's no correlation between a coin flip. It's a completely random act. And same thing with a poker hand. There's no way to have any sort of correlation in what cards you get in poker. It's completely and 100% random. Okay, and that's really it. I promise this time. See? That's for tomorrow.